All right, today we are moving on to logarithmic functions. You guys remember logs from Algebra 2? Okay. Hopefully we can get a better grasp on it today. So, um, real quick, it says y equals log. So, does anybody know how to read these? So it's log. You say base a of x. Okay. So we'll say. So everybody pay attention to the way I said that. It's log base a of x. Okay. So log base a of x. If and only if x is equal a to the y. So now, our last section we were talking about what? Exponentials. And now we're jumping into logarithmic. Why would I make it? Seems like such a far jump. It's actually very simple. Why? Because exponential functions and logarithmic functions are what we call inverses. They are inverses of each other. What's an inverse? It's kind of like an opposite, and you can actually see through the graphs here. So this was an exponential, y equals e to the x, okay? This is y equals e to the x, and this is the function, the natural log of x. So notice that they're basically symmetrical, right? They're basically symmetrical. They're actually inverses, so along this line of symmetry here, y equals x, they're pretty much the exact same graph, okay? So here is the big idea with logarithmic and exponential functions. Okay? So if you have any, what kind of equation is the top one? Well, look at it. What does it have? Has an exponent. So this is an exponential. And then, of course, the bottom one is a what? Because it has a... Okay? So, notice that exponential and logarithmics are basically the same thing. I just have to rewrite them. Okay? So, what did we call this 5 in a exponential? We called it the what? The base, right? So the 5 is my base, the 3 is my exponent, and then the 125 was my answer, basically. So if it's an exponential form, I can actually rewrite it in logarithmic form. The 5 is still your base, the 125 comes here, and then the exponent becomes your answer. Okay? So logarithmic and exponential functions are basically reverses. Okay? So if 5 to the third power is equal to 125, well then it's also true that log base 5 of 125 is equal to 3. So here's the rule. Okay? Here's the rule. If b to the y power is equal x, so b of course standing for base, y is the exponent and x is the answer, then it's true that log base b of x equals y. Okay? Now notice I drew two arrows. Log base b of x equals y. So b to the y power is equal to x, then therefore log base b of x is equal to y. Now notice, I drew two arrows. What do you think this means? They could go back and forth. So if it's exponential, I can write it as logarithmic. If it's logarithmic, I can write it as exponential. I just have to follow this pattern. Does everybody see that? Okay, so now why would I need to know this pattern? Okay, does everybody got that? Very important. This is literally just the rule we're going to be following the whole time. Okay? So, why would I need to know that? So, here's my question. My question is, f of x equals log base 2 of x. And then I'm telling you x is equal to 32. So write that out. F of x is equal to log base 2 of x, and then I tell you x is 32. So if you know x, obviously what are you going to do? Plug it in. So what is it going to look like? Can I change this to what? So y equals log base 2 of 32. Okay? Log base 2 of 32. You with me? Now, I need you to solve it. Therefore, what do I want to know? I want to know what is it equal to? Log base 2 of 32 is equal to what? So in this case, y. So now here's the thing. In log form, I can't do anything with it. But change it to exponential form. So change to exponential form. To solve. So let's see if you were paying attention. Okay? So, it was, whoops. Can I go back? Whoops. This is all being recorded, by the way. There it is. Alright, so there's my formula. Right now it's in this form, right? Log base b of x equals y, except I have the y where up in the front. Does it matter? No. So if I have the y up front or in the back, doesn't matter, right? So let's see if you can change it. So change it to exponential form. So what would it be in exponential form? 2 to the y is equal to? Do you see what question this is asking yourself? So in English, how would I say this? 2 to what power is equal to? So this is kind of what we've been asking ourselves in the last section, right? So when I was asking you to rewrite. So here I'm asking myself, 2 to what power is equal to 32? Does everybody agree with that? So then can you tell me what that is? 2 to what power is 32? 2 to the 5th power, right? Because remember, 2 times 2 is, times 2 is, times 2 is, times 2 is. Everybody got that? So does everybody agree that 2 to the 5th power is equal to 32? Agreed? So I just found my answer to the original. Why? So then y is equal to 5. So therefore, log base 2 of 32 is equal to 5. So what you do here, you have a logarithmic function. You're going to do the work in exponential because that's way easier for me to understand. But then I'm going to answer it back in logarithmic function. Does everybody see how that's going to work? Okay, let's try again. Okay? So I have y equals log base 4 of x, and then I tell you x is equal to what? 2. Okay, so here we go. What is my equation? Log base 4 of 2. So what am I going to do now? So then what is it going to be? So 4 to the power of what will give me 2? So, ask me a question. I know you have one. Did y'all notice something strange here? What? It's getting smaller. Normally when you take an exponent, what usually happens? It gets bigger exponentially, correct? So now I'm taking a number to an exponent and it's getting smaller. So that tells me something about my exponent. It's a fraction. Good, good, good. So, when the base gets smaller, very good. When the base gets smaller, the exponent is a fraction. Okay? The exponent is a fraction. When the base gets smaller, the exponent is a fraction. So Daisy already got the answer. So she also noticed this. Isn't the square root of 4 2? Right? The square root of 4 is 2. But didn't we learn that I can take a radical and change it to an fraction exponent? How? Do you remember? Like the square root is what fraction? I'm sorry, yeah, 1/2. So 4 to the 1/2 power is equal to 2. Okay? 4 to the 1/2 power is equal to 2. So then answer the original question. Log base 4 of 2 is equal to what? 1/2. Does everybody see how that works? So you're going to have to remember our rules, guys. You have to remember our rules. We learned earlier that when we had a fractional exponent, it was like taking a radical, right? So if you notice that, so there's basically a tip for you. When the base, guys, is going to get smaller, your exponent has to be a fraction. Okay? We okay? Why don't y'all try part C on your own? Try C on your own. Alright, so this says y equals log base 3 of 1. That's in logarithmic form. What is it in exponential form? What's your answer? Why? Anything to the 0 power is always equal to? So then 3 to the 0 power is equal 1, correct? So then log base 3 of 1 is equal to 0. We good with that one? Okay, the next one I wanted to do together. So here I have y equals log base 10 of 1 over 100. Let's rewrite it. What would it be? Ten to the y power is equal to 1 over 100. Okay, notice something here. It's turned into a fraction, right? So now I'm going from a whole number to a fraction. Do y'all remember one of our rules that maybe did that? Good. Our exponential rule said, look, when I have a negative exponent, what do I do to it? I turn to a fraction and flip it, right? So, but here's the thing. Here's the thing. If this was a let's just pretend this was a negative 1, right? If this was a negative 1, wouldn't this be 1 over 10? Right? But it's 100. So how did 10 become 100? To the 10 to, not to the 10th power, to the second power. So 10 to the second power is 100, right? So 10 to the second power is 100, agreed? So then, but if I want them to be fractions, it'd be the negative 2. So 10 to the negative 2 is 1 over 100. Does everybody see how that works? And if it was 1,000, then it would be 10 to the negative 3. Does that make sense? So sometimes when you see fractions, they're not going to be just the exact same base. The base might have changed as well. So you got to pay attention to that. Got it? So then log base 10 of 1 over 100 equals to what? Negative 2. Okay? So you can get negative numbers here because you can have negative exponents like we did before. Okay? So basically, do y'all guys see how this is essentially the rules of exponents? Right? It's just your rules of exponents, but instead I'm expressing them as logarithms. Any questions so far? Okay, we're actually almost done, or we're more than halfway in. So, here's the actual rules themselves. Here's the actual rules themselves. I want you to write them down, even though you essentially know them, but I want you to write them down. I'll give you some time and then we'll talk about them. Alright, let's go over these properties. Like again, you kind of pretty much already know them. So here, It says that log base a, and again, a can mean what? Anything. So log of any base of 1 is equal to 0. And it makes sense if you think about it this way. Wouldn't it be a to the 0 power equals 1? So it's exactly what I told you with exponential. Anything to the 0 power is equal to 1. Okay? So if I told you log base 12 of 1, your answer is 0. If I told you log base 25 of 1, your answer is 0. Everybody got that? Okay, next one. It says log base a of a is equal to 1. Now, these have to be the what? The same. If they're the same, then the answer is 1. And again, if you think about it, it would look like this. A to the first power is always itself. Right? So any base to the power of 1, isn't it just itself, right? So like 9 to the first power, it's just 9. 10 to the first power, it's just 10. That's exactly what this is saying here. Okay, now here, something interesting happens. So I have log base a of a to the x power. So I have a logarithm and an exponential function in the same thing. What did I tell you about logarithms and exponential functions? They're inverses. So if they're opposites, what happens? They cancel each other out. So look what happens. If this base of the logarithm and the base of the exponent are the same, they go away. So you're just left with the exponent. Does everybody understand that? So if I had like log base 2 of 2 to the 4th power, the answers, the 2's cancel, and you're left with just what? 4. Does everybody see how that works? Okay? And this one is essentially the same thing, except written differently. So if I have a base and a logarithm is my exponent, but as long as these bases are the same, they would what? Cancel, and I would be left with whatever the exponent was. Okay? So like for instance, if 3 to the log base 3 of 9, see how these bases are the same? They're going to what? And I'm just left with what? 9. Does everybody see how that works? Okay? Keep those in mind because they come in handy. They come in handy. Any questions with the properties? We good? Alright. Let's use these properties. Let's see if you were paying attention. Alright? Very simple stuff. Okay? Log base 4 of 1 automatically is what? 0. Why? Basically, it's asking me 4 to the y is equal to 1, and we already said anything to the 0 power is 1. Part B, I have 6 to the log base 6 of 20. The answer is? Why? They just cancel. Again, as long as those bases are the same, what happens to them? They cancel out. Very simple. We good? Yes? No? Alright. Okay. So here we go. We have something called the one-to-one property. Do you guys remember the one-to-one property in the last exponential? Well, what did the one-to-one property say? If the bases are the same, essentially I can what? Ignore them and set the exponents equal to each other. In this case, though, I have no exponents. I'm dealing with the logarithms. But don't logarithms also have bases? Right? So, like for instance here, I have log base 3 of x equals to log base 3 of 12. Log base 3 of x equals to log base 3 of 12. So, what's the base of the left side? What's the base of the right side? So, same bases. So then set what's left equal to each other. What do I have? Simple as that. We good with that? As long as the bases are the same, you can basically ignore them and just set whatever's left equal to each other and solve. Good? Okay. Something interesting in B. So I have log of 2x plus 1 equals log of x. Log of 2x plus 1 equals log of x, okay? So Bonnie already said it. What's not there? So here's the thing. By default, guys, by default, missing bases are base 10. Okay? So if it's not written, it's automatically base 10. Look at your calculator. Look at your calculator. You have a logarithmic button. You guys see where your log button is? Okay? It's over here next to your 7. See how it just says log? So if you press it, if you press log, it asks you log of what? And you can say, I don't know, 5. But notice what's not there? A base. So automatically this is base what? 10. So that button is automatically log base 10. Okay? And then you can figure out what you need. So in this case, my bases are what? They're the same. So I can do what? Ignore them. So what do I have? 2x plus 1 equals x. Help me out. So technically it doesn't matter, right? The rule, move the x's together, right? The rule is to try and move the which one? The smallest. So get rid of this one. So you're going to do it eventually, so it really doesn't matter. Okay, so I'm going to move this one. So if I move this one, what am I left with? 1x plus 1 equals 2? 0. If nothing's there, write a 0. And then now what? So x is equal to? Negative 1. Okay? So what you get from this example is if there's no base, it's base what? 10. If there's no base, it is base 10 by default. Okay? We good? Pretty easy stuff, right? Is this new? No, right? It's algebra 2? Or what you learned in algebra 2? Oh, and that's it. Okay? So, in the next section, we're going to be tying it all together. We're going to get it a little bit more complex, okay? So this was basics of logarithms. We're going to see how they're used.